Hello friends, myself Rajendra Mahajan presenting my video on division by t theorem of Laplace transform. First of all, we see the statement of the theorem. The statement is like this: if Laplace of f of t is given as f bar of s, given or obtained, we can obtain it, that is f bar of s, then Laplace transform of that function f of t divided by some t, Laplace of f of t by t, is given by or obtained by integration from s to infinity of that f bar of s. F bar of s means the Laplace transform of that function f of t, provided that limit of f of t by t as t tends to 0 exists. If this limit exists only, then only we can obtain the Laplace of that by using this theorem. Then after this, we try to solve some simple example based on this theorem. Therefore, in this video, I am discussing 5 different examples. Therefore, watch the video up to end so that all 5 examples are clear to all of you. The first one, e raised to at minus 1 upon t. Second one, sin t by t, find the Laplace of it. Third, sin hyperbolic at divided by t. A fourth one, 1 minus cos at divided by t. And the fifth one, it is cos 2t minus cos 4t by t. Therefore, these are the 5 different examples for which we have to obtain the Laplace transform using that division by t theorem. Therefore, first of all, first example, Laplace of e raised to at minus 1 by t, we have to obtain this. Therefore, here the function f of t is e raised to at minus 1, whose Laplace transform is known, or we can obtain it as a standard result. Laplace of e raised to at as 1 upon s minus a, s greater than a, and Laplace of 1 is 1 by s. And we call this is f bar of s, say. Okay, then as it is divided by t, we have to apply that theorem. By that theorem, Laplace of e raised to at minus 1 by t is equals to integration from s to infinity of f bar of s ds. Therefore, whatever that value of f bar of s we put here in that integral, and therefore it is integration from s to infinity of 1 upon s minus a minus 1 by s, and its integration with respect to s. Using standard result of integration, 1 by x, integration is log x, and therefore it is log of s minus a minus log of s, and limits from s to infinity. Then property of log, log a minus log b is log a by b, therefore it becomes log of s minus a divided by s, limit from s to infinity. We are not able to substitute the limit directly here. What we do, we rewrite it by taking s common from numerator and denominator. We get log of, taking s common from numerator term, we get s into 1 minus a by s and divided by s, so that s's get cancelled, and limits from s to infinity. And then we put the limits. A by infinity, any number by infinity we get 0. Therefore, it is log 1 remains. A by infinity 0, therefore it is log 1 only, minus log of 1 minus a by s, or cross multiplying it, we get s minus a divided by s. Standard result of log 1, value of log 1 is 0, therefore it is 0 minus log of s minus a upon s Then multiplying by minus sign, we get value as log s upon s minus a. The terms are interchanged. Numerator term goes to denominator and denominator goes to numerator after subtracting the limits. Therefore, this is the Laplace of that first example, e raised to at minus 1 upon t. Very simple. Then we go for the second example. Find the Laplace of sin t by t. Again, very important example. We require this as a standard result when we go for the study of Fourier transform. Therefore, here the function is sin t whose Laplace is known. Therefore, Laplace of sin t as a is here 1, therefore 1 upon s square plus 1. We call this as f bar of s c. Then in next step, we apply that theorem. Therefore, by that theorem, Laplace of sin t by t is equals to integration from s to infinity f bar of s and its integration with respect to s. It is equals to, substituting the value, we get integration from s to infinity 1 upon s square plus 1 and its integration with respect to s. Standard result from integration, it is tan inverse of s by a is here 1 and limits from s to infinity. Tan inverse of infinity minus tan inverse of s. Again, standard value for tan inverse of infinity, it is pi by 2 minus tan inverse of s. We can write answer in this form, or again a standard result from trigonometry, pi by 2 minus tan inverse theta is nothing but cot inverse of theta, means it is cot inverse of s. Both answers are correct, either pi by 2 minus tan inverse of s, or in simplified form it is cot inverse of s. Then we go for the third example. Find Laplace of sin h a t by t. Function is hyperbolic function. Therefore, here the function f of t is sin hyperbolic a t, whose Laplace is known as per the standard result. We know that Laplace of sin h a t as a upon s square minus a square, s greater than a, and we call this as f bar of s a. First step. In second step, we apply that theorem. Therefore, by that theorem, Laplace of sin hyperbolic a t divided by t is equals to integration from s to infinity of f bar of s ds. Then substituting value, we get integration from s to infinity. F bar of s is a upon s square minus a square and its integration with respect to s. A is constant term, we take outside the integral sign, and we take the help of the standard result from integration. Integration of 1 upon x square minus a square with respect to x is 1 by 2a log of x minus a upon x plus a. This is known result to all of you. Therefore, we have to apply that result here. And therefore, it is the value of that previous integral is a outside 1 by 2a log of s minus a upon s plus a. X is here s. Therefore, s minus a upon s plus a, bracket close, outer bracket close, limit from s to infinity. Substituting the value, but before that we take s common from the numerator and denominator term. Therefore, it is 1 by 2a outside, a get cancelled, therefore 1 by 2 remains, log of s in bracket 1 minus a by s. From denominator also we take s common, 1 plus a by s, so that ss get cancelled, and then we substitute the limit as s and infinity. Upper limit infinity, we get log of 1 minus a by infinity means 1 minus 0, that is log 1 upon 1, therefore it remains 1 only. Therefore, for upper limit we get log 1 minus log of, for lower limit we get s minus a upon s divided by s plus a upon s. S get cancelled and therefore we get log s minus a upon s plus a. It is in the form of log a minus log b, nothing but log a by b. Log 1 is 0, therefore we neglect that term, and multiplying by minus sign inside, we interchange the terms. Therefore, final answer becomes 1 by 2 log of s plus a upon s minus a as the Laplace of sin hat upon t. A required answer. Then fourth example, Laplace of 1 minus cos at divided by t. Therefore, function is here 1 minus cos at, whose Laplace is known or we can obtain by the standard result. Therefore, Laplace of 1 is 1 by s, and Laplace of cos at as s upon s square plus a square. And this we call as a bar of SA. Then, by that theorem, division theorem, Laplace transform of 1 minus cos at divided by t as integration from s to infinity of f bar of s with respect to s. 2 steps only. Integration from s to infinity, the values are 1 by s and minus s upon s square plus a square. We have to integrate these two terms with respect to s. Integrations for the first is log s, and for second we multiply and divide by 2 so that it is in the form of f dash upon f, whose integration is log f. Therefore, it is minus 1 by 2 log of s square plus a square. Bracket complete and rest infinity, limit from s to infinity. Log a minus log b is log a by b, therefore it becomes log of s upon 1 by 2 we take as a power, therefore it becomes square root of s square plus a square as per the laws of logarithm. M log n is nothing but log n raised to m. Limit from s to infinity. Again, further simplification, taking s common from the denominator by taking s square outside the square root sign, it becomes s only. Remaining terms are 1 plus a square by s square. Bracket close. SS get cancelled and limit from s to infinity. It is 1 by square root of 1 is 1 and a square by infinity is 0. Therefore, it is log 1 first term minus, for lower it becomes s square square root of s square plus a square and whole divided by s. Log 1 is 0 minus log of that 1 upon 1 by s goes to numerator as s divided by square root of s square plus a square. Multiplying by minus inside the bracket, we get log of square root of s square plus a square divided by s. Terms are interchanged. This is the required Laplace transform of 1 minus cos at divided by t. Therefore, Laplace of 1 minus cos at by t as log of square root of s square plus a square divided by s. These two terms are inside the log. Then last example, find Laplace of cos 2t minus cos 4t and divided by t. Here the function is cos 2t minus cos 4t, whose Laplace transform we can write by using standard result as, for first it is s upon s square plus a square. A is here 2, therefore that becomes s upon s square plus 2 square. And for second, same result, therefore s upon s square plus 4 square. And we call this as f bar of s. See, then by that theorem, Laplace transform of cos 2t minus cos 4t and whole divided by t, it is integration from s to infinity of that two terms, s upon s square plus 2 square minus s upon s square plus 4 square. Nothing but the value of f bar of s. Therefore, substituting that value of f bar of s is here. And then derivative of s square is 2s. Therefore, multiplying and dividing by 2, rearranging the term, is equals to 1 by 2 log of s square plus 4 divided by s square plus 16, limit from s to infinity. And then interchanging the terms, as already I have explained how we can get that. Therefore, here I am not performing that step. By interchanging, we get final answer as log of s square plus 16 divided by s square plus 4. That read that two steps carefully, we get that required result. Therefore, 1 by 2 log of, as log 1 is 0, that term becomes 0, and then multiplying by minus inside, we get log of s square plus 16 divided by s square plus 4 as the required Laplace transform or the required answer. Therefore, in this video, I have discussed these 5 different examples with step-by-step procedure. Therefore, watch the video completely. If you have any doubt, please write in the comment box. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.